So here in this problem, we have three lines whose equations are given to us. And it's given that these three lines are concurrent. That means they meet at the same common point, or they intersect at the same common point. And here A, B, and C, these are non-zero numbers. We need to show that 1 over 1 minus A added to 1 over 1 minus B plus 1 over 1 minus E, that's equals to 1. Okay, let us begin. So we'll start with the three equations of the line. So here we'll suppose that the line L1 is represented by the equation ax plus y plus 1 equals to 0. Then we have the second line L2, which is given by x plus by plus 1 equals to 0. And then we have the third line L3, given by x plus y plus c equals to 0. Now it's given that these three lines are concurrent. Now we know that the condition for concurrency states that we'll have a 3 by 3 determinant, which is obtained by, so in the first row we're going to use the coefficients of x, y, and the constant term of line L1. So we have a the coefficient of y, that's 1, and then we have the constant term, that's 1. So those are going to be elements in the first row. Then the elements of the second row R2 is going to be the coefficient of x and y of line L2, including the constant term. So here we have 1, b, and 1. And then finally in R2, we're going to consider the coefficients of x and y of line L3, including the constant terms. So we're 1, 1, and c. Now, if these three lines are to be concurrent, then this determinant must be equals to 0. That is the condition for concurrency. Now what we'll do, we're going to expand this determinant. So expanding it along the first row, we're going to get a multiplied to, we have b times c, so that's going to give us bc, minus 1 multiplied to 1, so that's simply 1. So we have a times bc minus 1. Then the next term will be negative, so we're going to consider this element, negative 1 multiplied to, so we now have 1 times c, so that's positive c, minus 1 multiplied to 1, so that's going to be simply 1. Then added to the element in the first row, third column, so that's simply 1. The 1 is going to get multiplied to the product of 1 and 1 minus the product of 1 and b, so that's simply b. So this is going to be equals to 0. So let's simplify this. So we're going to get a, b, c minus a, so negative 1 times c minus 1 makes it negative c added to 1 plus 1 minus b equals to 0. So we now have ABC equals to the a, negative b, and negative c. Transpose it to the right hand side to get a plus b plus c. And they have 1 and 1 added to each other, so it becomes positive 2. Transpose it to the right hand side to make it negative 2. So this is going to be a relationship between a, b, and c. So we have ABC equals to a plus b plus c minus 2. We're going to take this help to prove our problem. Now let's come to the problem. So what we'll do, we're going to start from the left hand side, and we'll show that that's equals to 1, which is the number that we need on the right hand side. So we have on the left hand side 1 over 1 minus a, added to 1 over 1 minus b, added to 1 over 1 minus c. All we have to do is simply combine these three fractions. So we are going to have a common denominator. So that is going to be the product of all the three terms in the denominator, 1 minus a, 1 minus b times 1 minus c. Then in the numerator, for the first term, we have 1 minus b multiplied to 1 minus c. Added to the second term will be 1 minus a times 1 minus c. And in the third term, we have 1 minus a multiplied to 1 minus b. Okay, let's expand both the numerator and the denominator term. So we have 1 minus c minus b plus bc. Then we have 1 minus a times 1 minus c, so that's going to become 1 minus c minus a plus ac. Added to, so we have 1 minus a times 1 minus b, so that's 1 minus b minus a plus ab, whole divided by, well, we have the product of 1 minus a times 1 minus b times 1 minus c. So that is going to become 1 minus a plus b plus c. Then we have plus ab plus bc plus ca. Then we have negative abc. So let's work with the numerator portion. So we have 1 occurring 3 times. So we have plus 3 in the numerator. Then we have negative A occurring twice. Similarly, negative B also occurs twice. So what we'll do, we'll take negative 2 as the common factor. That gets multiplied to A plus B plus C. And then we have the remaining terms. That's going to be plus AB plus BC plus CA whole divided by. So now in the denominator, we have 1 minus A plus B plus C added to AB plus BC plus CA. Now we have negative ABC. So let's use whatever we obtained for ABC in equation number 1. So replace ABC with A plus B plus C minus 2. So we should get negative A plus B plus C. So negative of negative 2 makes it positive 2. Right? So as we can see here, this 2 and this 1 gets added to make it 3. So we are now going to get, we have 3 minus A plus B plus C and negative A plus B plus C, that gets combined to give us negative 2 multiplied to A plus B plus C added to AB plus BC plus CA. Now the numerator and the denominator is exactly the same, so they are going to get factored out, leaving us with 1, which is the expression on the right hand side. And we have successfully verified the problem. So here we have showed that the left hand side equals to the right hand side, hence proved.